This is Li Qing from National University of Singapore. I'm currently a PhD student in architecture. Today I'm going to share mitigating urban heat island effect through integrated climate-sensitive planning framework, a study based in Singapore. Urban heat island is known as one of the severe environmental problems, especially in tropical regions like Singapore. This research aims to provide an integrated climate-sensitive planning framework to UHI mitigation by understanding urban morphology. In step 1, DEM data of a specific urban area is used to calculate the sky view factor in GIS tool. Air temperature increment is then calculated based on the sky view factor. The result is visualized as an UHI distribution map, and according to which target area of district level with UHI issue will be identified. Then in step 2.1, the wind permeability of this certain district area will be further mapped using the same DEM data, but with annual wind frequency data in the calculation. Specific wind frequency data of certain periods like monsoon season can be also used for later validation of the potential air paths. With heat and wind permeability information, proper spatial implication can be adopted, and thus, evidence-based urban design can be developed. Here comes the Singapore case. In step 1, from UHI distribution map of Singapore, we can see that the surrounding area of Paya Lebar airbase is identified as area with UHI issue, with the intensity around 2 to 3 Celsius degrees. Not to mention that with further development, there is a potential risk to create a more spreading UHI. In step 2.1, the urban permeability of Paya Lebar airbase and surroundings is mapped to detect the potential air paths. As we know, 2 monsoon seasons characterize Singapore's climate. The northeast monsoon happens from December to March, while south monsoon happens from June to September. The potential air paths can be well validated by the specific wind frequency data in monsoon seasons, which proves the effectiveness of this wind detection method. In step 2.2, spatial implications are summarized as schematics. For separating UHI clusters, we have buffer zone and the control over canyon aspect ratio in building geometry. Regarding creating wind paths, we can make use of arterial roads, green corridors, and low-rise built areas properly to form the potential breezeways. Varying building heights is also an effective way to introduce fresh air into the street canyon. When implementing proper spatial implications, initial urban design can be developed by integrating them. From the computational morphological study to the initial urban design, this study aims to enhance the accuracy and efficiency of pilot study on the environmental assessment in the initial urban planning stage by developing a climate-sensitive planning framework. This framework is generally applicable to tropical regions with cooling needs, as the key is to minimize temperature rise due to long-wave radiation while introduce cool air to the site. That's all I want to share today. For more information, you are welcome to visit our lab website. Thank you.